Here are some problems in flotation. The first problem involves recovery of a certain material by flotation. It is desired to recover lead from an ore containing 10% lead sulfide and the balance assumed to be silica. 100 pounds of ore being treated per 24-hour day. It is assumed that the concentrate from a single cell is of acceptable purity, but the tailings are to be treated in scavenger cells with return of scavenger concentrate to the rougher. Laboratory findings indicate that if the water to solids ratio equals 2 and the contact time is 8 minutes in the rougher, and the water to solids ratio equals 4 for 15 minutes in scavenger, with mechanically agitated machines for the Denver type, the following compositions will be found for the various products. Note that the numbers presented here are in weight percent basis. Now, the required parameters will 1. The percent yield or percent recovery of lead sulfide, and 2. The capacity of the rougher and scavenger tank. The process would look something like this. To get the percent yield, we will use the formula percent yield equals the amount of desired material in the concentrate over the amount of desired material in the feed times 100. The amount of the desired material in the concentrate and feed stream is obtainable by performing overall and component material balances. Performing an overall material balance throughout the system, we will have the expression as shown in equation 1. Obtaining the lead sulfide component balance throughout the system, we will have the expression as shown in equation 2. Solving equation 1 and equation 2 simultaneously, we will have B equals 11.9 pounds and E equals 88.1 pounds. Performing an overall and component balance throughout the scavenger tank, we will have equation 3 and equation 4. Solving equation 3 and equation 4 simultaneously, we will have C equals 102.67 pounds and D equals 14.57 pounds. Substituting the appropriate values, we will have percent yield equals 95.2%. Now, to obtain the capacity of each tank, we must get the average density of each stream. The equation to obtain the average density of a mixture is given by XB over rho B equals X1 over rho 1 plus X2 over rho 2, where X is the mass fraction of the desired material at a certain stream, and rho is the density of the solids present in that stream. In the case of feed, substituting the corresponding values would give us the average density of the solids in the feed stream to be 176.5 pounds per cubic feet. For the other streams, it is summarized in the table shown. For the rougher tank, only solids from stream A and T are present. Thus, obtaining the average density of the solids in the rougher tank would give us 176.8 pounds per cubic feet. To get the volume of solids per volume of mixture, the volume fraction of the solid represented by eta is computed. Substituting the proper values will give us eta equals 0.4092. This means that per unit volume of mixture, there is 0.4092 units of volume of solid present. To get the capacity, we will use the formula Q equals eta rho T over theta, where Q is the capacity, eta is the volume fraction of the solid, rho is the average density of the solid in the tank, T is the operating time, and theta is the residence time. Substituting the appropriate values would give us Q equals 2.378 tons solids per cubic feet day. Now, to obtain the scavenger tank capacity, we must get the volume fraction of the solid in the scavenger tank. Substituting the values would give us eta equals 0.0851. This follows that the capacity of the scavenger tank is 0.682 tons solids per cubic feet day.